Hi girls, it's Miss Julie. Welcome back to another virtual lesson. I hope you guys are still staying safe and having fun. And as always, I'm encouraging you guys to try something new, do something, maybe you haven't done in a long time or you find interesting and would like to try. So today we are going to be talking about the Earth's layer. So I went ahead, so you guys can do this too. I drew a circle like this, and I only colored half of it. So on half of it, I put some land, so that's the green, and the other half, I put some blue, and that's the water. So go ahead and draw this, have this ready, because on the other side, we are going to be drawing the layers, and then kind of, you can see, this is what it looks like on the outside, and then this is what it looks like on the inside. So it looks a little bit different on each side. You can use different colored markers to draw the layers. I'm just gonna use just a regular one just to draw and label it. And then I have written down some facts that you can put either by each layer or to the side or behind it, so you can really know what each layer is and like what it's like in that layer. And some of it's actually pretty cool and fun to learn about. So when you start at the center of the Earth, the very center on the inside, it goes from the deepest layer to the shallowest layer. So we have the inner core, that's the deepest, and then we have the outer core, then we have the mantle, and then the crust. The crust is, what we see, the crust. So we have the inner core, the outer core, the mantle, and the crust. So here's a fun fact: except for the crust, no one has ever been able to explore these layers fully. It's because they are so deep down that by hand we have not been able to get down that far. That information might be a little outdated. That's just what it said on my end. But the deepest that anyone has ever been able to drill, and this is in kilometers, so 12 kilometers, but to change that into miles, it's 7.6 miles, and that took over 20 years to get that deep. And there's reasons for that. It's because these layers are so thick and dense, it's hard to drill through them. And they're really, really far down. And I've written down how far and deep they are within the Earth, so you can kind of know why they've only been able to get down 7.6 miles. So since they have not been able to really get down to these layers, the reason why scientists kind of know about each layer is because of different events. So like when earthquakes happen or different things like that, they are able to study that and kind of track it back to the layers, and then just study it and then know, when it travels throughout that layer or travels throughout the world, it's more dense in certain places, and so it just lets them get to know a better idea. So they calculate, the Earth's density. So from those calculations, they can know about these layers, the gravitational pull, the magnetic field, and actually we'll talk a little bit more about those last two things because they actually come from one of the layers. So to start out, we have our Earth right here. So the first thing we're going to do is we are going to draw our inner core. So this one's going to be tiny. I'm going to draw it really quick and then show you. So this is the deepest layer, and it's called the inner core. So I'm going to label it inner core. All right, so right there. So the inner core is the deepest. So it's right there. So you can see the inner core. So go ahead and label that, and then I will tell you a couple facts about the inner core that you can write down or maybe learn that you didn't know about. So the inner core is a solid metal ball, and the radius is 758 miles. It's located about 4,000 to 3,220 miles beneath the surface. So 4,000 miles beneath the Earth's surface. So it's extremely dense because it is so far deep, and it is made up of iron and nickel, which those two are metals. So it is a solid metal ball. The inner core actually spins faster than the rest of the Earth. And then it is extremely hot. So it's 9,800 degrees in Fahrenheit. And then in Celsius, that's 5,400 degrees in Celsius. So you can see why it's hot. 9,800 degrees in Fahrenheit. That's very hot. That's almost as hot as the surface of the sun. And the pressure is 3 million times greater than Earth's surface. So a fun fact about the inner core is some scientists believe that there might be an actual inner core that's made up of complete iron. So they think within the inner core, there's going to be another one that's made up of iron. So where that inner core is right there, they think there actually might be one inside of it, but that has not been proven yet. Some scientists just believe that. So that's our inner core. Next, we have our outer core, and you can guess it just goes on the outside. So just kind of make another one of those. So we have the outer core. Also, if you want to color like I did this Earth, I did not have markers. I just happened to have blue and green pen, so I colored with the pen. So the outer core, which is the second deepest layer, so we have the inner core and the outer core. The outer core is iron and nickel, just like the inner core, but this is in liquid form. So the outer core is in liquid form. It sits 3,220 miles to 1,790 miles below Earth's surface. It is heated largely by radioactive decay. The motion of this generates electrical current. So this is where it generates the Earth's magnetic field. Because of that radioactive decay that's going on within this outer core, it is so high that it's generating the magnetic field on Earth. So that's, that gravitational pull, all that. And then a fun fact about this is it actually reverses about every 200,000 to 300,000 years. Again, they're still trying to discover why. My information might be a little outdated. Maybe they know why, and I have not learned why. But that's still kind of a mystery. So that is the outer core. Next is the mantle. So we have the inner core, the outer core, the mantle. And this one's actually a little bit larger. So I'm going to draw the mantle and then show you. It's a little larger than the other two. So we have our third one, and that's the mantle. So you can see I got really close to the edge of the Earth right there. So that's what you want to do. That's the mantle. So the mantle is the thickest layer by far. That's why it's really big. It is about 1,865 miles thick. So it's very, very thick. The mantle sits about 18.6 miles beneath Earth's surface. So that's why we drew it kind of close to Earth's surface right there. It's mostly, those metals, the iron, magnesium. So before it was like iron and nickel. This is iron, magnesium. It's very dense. It's hot and semi-solid. So some people kind of compare it to like a thick caramel candy. It circulates just like the outer core. It's just a little more slow than the outer core. So that inner core is the fastest, and then the outer core and the mantle is more slow than the other two. The near upper edges of the mantle, the temperature reaches that melting point of a rock. So some of you might have learned that melting point of a rock, what that is, to where it gets hot enough to where it can melt a rock. So because it does this on those upper edges, it forms a layer of melted rock and partially melted rock. So there's a thick layer of that on the upper edges of the mantle. Diamonds actually come from the mantle. So little diamonds are tiny pieces of mantle that we can actually touch. And they believe that deep down there's deeper diamonds that we just can't get to, and they're going to be bigger than those tiny diamonds we see. And then the outermost layer is relatively cool and rigid. So the upper edges, that's where it's hot, and then above that is the outermost layer, which is going to be relatively cool and rigid. So the last one we have is the crust. We don't have to draw anything for this one because this part right here, that tiny part, that is the crust. So I'm just going to draw a line right there. So that's the crust. So we have the inner core, outer core, mantle, and the crust. The crust is similar to a hard-boiled egg. It's thin, it's cold, and it's brittle. It's broken into pieces, so that's our tectonic plates. Some of you might have learned about this in school. If not, you will eventually. Tectonic plates are what causes earthquakes and volcanoes to happen, because over time they shift and move, and when that happens, one tectonic plate can go underneath another one, causing that earthquake, or they can, to form a volcano, they kind of collide like this and they move up. So they break that crust and they break Earth's surface, and they kind of move up to form that volcano. So that's where those things come from. They come from the crust layer. And then the thickness actually ranges from each place depending on where you are. Just like, you know, when I was saying the layers below Earth's surface, it kind of went from different numbers. So for example, the outer core was 3,000 to 1,000 miles below. It just kind of ranges. It's different. But the crust is the shallowest layer compared to the inner core, which is very deep. The crust is where we get those tectonic plates and different occurring events like those earthquakes and volcanoes. So I hope you guys learned a little bit about the Earth layers, why each layer is important, how each layer is different, how each layer does different things. But I hope you had fun doing this. It's actually very neat to learn about, and I encourage you guys to look up more information about it. So I will see you guys next time. Bye!